Watch a ROS2 robot navigate through a maze completely on its own, planning paths, avoiding walls, and reaching goals autonomously. Nav2 is the navigation stack for ROS2. It takes a map, localizes the robot with AMCL, plans a global path, and tracks it with a local controller, all while recovering from stuck situations automatically. This project auto-detects your hardware at launch. If an NVIDIA GPU is found, it runs a high-resolution Lidar at 10 Hz. On CPU-only systems, it drops to a lighter configuration so everything stays smooth. Navigation needs a map. We include a pre-built occupancy grid generated from the known wall geometry, or you can build your own map using SLAM mode, just like the previous tutorial. The Nav2 Params YAML configures the full stack. AMCL for localization, NavfnPlanner for global path planning, the DWB local controller for trajectory tracking, and recovery behaviors like spin and backup. The launch file brings up Gazebo, the robot, the ROS bridge, and the entire Nav2 stack. It detects the GPU at startup and picks the matching URDF and rendering settings automatically. In RViz we display the map, both Costmaps, the global and local paths, the AMCL particle cloud, and the laser scan. You can send goals by clicking the 2D nav goal button and clicking anywhere on the map. To run it, bash run.sh launches everything. Bash RViz.sh opens the navigation display. Then click a goal in RViz, or use navigate.sh from the terminal, or run Waypoints.sh for an automated maze tour. And there it goes. The planner finds a path through the corridors, the DWB controller steers the robot along it, and when it encounters a tight turn or obstacle, the behavior tree triggers a recovery spin or backup before replanning. The Waypoint follower script uses Nav2 simple commander to send the robot through 7 goals across the entire maze, visiting every room and corridor, then returning to the start. Full code is on GitHub, link in the description. Subscribe for more ROS2 tutorials.